Dr. Yasar. Okay, go ahead.
Okay, thank you. Bismillahirrahmanirrahim. Okay, last 2 days, actually, we were in a journey to help State of Palestine to implement their national implementation plan. And we had a lot of discussion regarding the inventories and the various guidelines and information regarding the various persistent organic pollutants. So after the inventory means we have to do the monitoring and assessment. So before we are going for the monitoring, we have to do when we are going for the monitoring, we have to do the proper sampling and analysis. So here I will talk about sampling and analysis of soils and sediment at POP's contaminated sites. Okay, uh, as we are thinking like suppose if we want to monitor somewhere, like where we have to do our monitoring, means simply we couldn't do here and there some monitoring, and it is not a right way. So we have to do the proper inventory, then we will make out where is our hotspot region or where is our contaminated site. So in those sites we will select some area, and there we used to do the proper monitoring. So before I am starting the sampling and analysis, I will have a just brief on. Okay, 1 minute. What happened? Yeah, I will have a brief briefing of the site contamination. So like what you mean by the site contamination, like site contamination exists where chemical substances are present on or below the surface of a site and result in actual or potential harm to the health or safety of human beings or the environment that is not trivial, taking into account current or proposed land uses. Then before we are going the monitoring, we have to follow some general principle. That is like we have to prepare some standard operating procedures. For that thing, always we have to be practicable. Means we have to be practical. Means we don't want to just think only about the developed countries. We have to think about the developing countries as well. And our standard operating procedure should be practical and easy to implement in developing countries as well. Then improve the ability of countries to produce the comparable data. Then we have to go for the strive for simplicity and clarity of sampling program design, and establish a clear expectation for analytical performance like QA and QC. Then provide a consistent framework for future sample collection. Now we are in the field sampling mission. So for the field sampling mission, we have like pre-field planning until data treatment and communication. So before I am explaining this thing, like whenever I am going for a field work now and before, actually suppose we have a field work on tomorrow, we used to get a mail, means like today we used to get a mail that you have to prepare all your material before you are going for a field work. Like sometimes we have to take the bottles, sometimes we have to carry the some instruments, then sampling equipments, sometimes we have to carry the storage box, ice box, bottles, GPS, uh, markers, pen, like first aid accessories. All these things we have to carry, and we have to make sure that all these things are to be ready before we are going to the field work. And one most important thing is that our sampling equipment, we have to test it should working properly. Otherwise, once we are going for a field work, maybe we are going inside a sea or in the estuary or in the dams or in some local areas. It might be far from our laboratory or from our institute. So once we reach in the site, if our instrument means if our sampling equipment is not working properly, then the day has gone. So we couldn't do anything. Then we have to come back and we have to prepare everything from the beginning. So before that, we have to check all these things working fine or not. Then like in the pre-field planning, we have to do these things as well, like assembling the crew, field work instruction, safety plan, training and briefing field crew, assemble equipments, then the field sampling like a collection of samples, labeling, recording, storing, chain custody forms. Then once we are in the field sampling, we have to do the proper sampling. Then after that, we have to do the proper transportation and storage. Then we will reach in the laboratory. Suppose if we are not doing our sampling on the same day, we have to do some proper storage technique.
هاي امجد قاعد يحكي معي شو سوى بقول لي حط محامي وبيعرفش عن هاي امجد بقول بدي يسال احمد طلب.
Excuse me, someone
يا
has...
شباب اللي فتح المايك رجاء بس يسكر المايك.
Okay, sorry. So once we are in the laboratory, if we couldn't able to do our analysis either means on the same day, we have to do proper storage, like in the cooler or somewhere in the means we don't want to contaminate our samples. Then QA and QC, finally in the data treatment and the communication. Now we have like field sampling design. Before beginning a sampling program, it is important to first identify the goal of the program. Like suppose we are going for a field work, like we will go like as a group of people. So the objective of this work or this project and the goal of our field work only knows our chief scientist and 1 or 2 persons. And others people doesn't know why they are going for the field work. If they don't know the objectives or goal of this field work, they will just come like in the field as like a sightseeing. Then they will do something and they will go back because they don't have any care or they don't know exactly what they have to do. They are just coming and they will just follow the instruction. Then they will just collect the sample and go. Actually, this method will make a lots of errors in our final result. So we have to make them understand that what is our exact goal of this field work and make them understand that these are our objectives. Then they will be very vigilant and they will be careful during the sampling, and in the end we will get our fruitful result as well. Then we have to check like what are the information already exist for the site. How can we do this thing? Like hello.
Yes,
Hello?
yes, we hear you, but
Yes.
there is no presentation on the screen.
Okay, 1 minute. Okay, 1 minute. Sorry. Did I lose from here?
Yes.
Okay.
Yes.
Fine. Thank you. Okay, so we have to collect like what are the information that you have. Like how can we do this thing? We can just make a questionnaire from like the people whoever is there, and we can take the like what are the information is already like maybe like already they have published papers they have and some technical reports they have. So you have to take that thing, and whether like what are the source of contaminant and who is possibly exposed, and what are the pathways linking to the contaminants to the pupil, and of course finally the budget as well. And I think in the case of Palestine, I think we are really looking for this budget as well. Then next slide. Yeah, quality assurance and quality control. Actually, it is important that the assurance and quality control has to be done for each like each sampling and analysis. And we have to use like disposable latex gloves must be used. For what we have to use these disposable gloves? to handle all the sample and specimen and should be changed between the samples and or specimen. Then we have to clean our stainless steel. It must be rinsed in distilled water, then acetone and hexane before each use and between the sample collection. Then the sample jars must be pre-cleaned. Then multiple samples should be collected at all sampling locations. So if subset, like if we have like a different subset of the sample, and we can do like a different assessment methodology, and the result of different assessment methodologies we can be compared and we can do the statistical analysis. Then of course sample must be appropriately labeled, stored in a cool or dark area, and if cool or dark area, and the location details with GPS, then interview with local residents. Then now we have the field equipments, like what are the field equipments that we need to take. Like this I am showing like normal equipments and materials that we are going to take for the field work. For the soil and sediment survey equipments like grab, coders, like trays, utensils. Then the general electronic equipments like GPS. Of course, like once we are in the field, we should know the latitude and longitude. For that, we have to carry the GPS system. And sometimes we have to take the photographs of our contaminated site, or maybe we will see some interesting things. So it is better to carry a digital cameras with you. And if you have like some laptop or computers, it is good for the communication things. Of course, a vehicle for the transportation. And we have to be very careful about the safety gear because we don't know if some accident will be happen or not from the field. So you have to carry like some first aid kits, gloves, safety glasses, hat, etc. And you can carry the reference materials, like if you have the topographic maps, then you can bring that one, then hydrographic chart or satellite or aerial photos, and if you have any previous report or publication that you can take with you. Then the miscellaneous field equipments like tarpaulins, coolers, buckets, hoses, sample bottles, etc. Then we are in the soil sampling methodology. So we have to do the soil sampling methodology, like individual grab soil sample should be collected at location throughout the hotspot, and if possible, these should be randomly selected and equally spaced. The presence of a notable difference in physical soil quantity may necessitate the preferential selection. Like suppose, like if you have a nearby site and if we are feeling that there will be a physical characterization different, like temperature or pH, if we have feeling that if it is changing, we can take like some extra subset of sample. Then soil sample should be collected using a stainless trowel or shovel, and can be collected approximately like near the top 10 centimeter depth, that is the surface soil. Then the sample will be deposited into a stainless steel tray and will be stirred into homogeneous mixture. Then sample will then be placed into one or more 125 or 250 ml glass jars. So first we have to do some pre-sample preparation. First we have to identify or locate our soil sampling site, then fill out field data sheet, then prepare sampling jars. Then we have to clean our soil sampling equipment. First, we have to make sure that we are clean, and we have to save ourselves. So put on your gloves and rinse gloves with clean water. This will help to avoid the contamination from your hand to the sample and the vice versa. Then we have to first scrub the equipment with spark clean, then rinse with water like 3 times, then rinse with acetone, then rinse with hexane. Now we are in the soil sampling, means now we are in the contaminated sites or hotspot region. Now how we will proceed our soil sampling steps. So I showed here each steps like by photographs. So first, of course, we have to fill the location information. That thing we have to do in the first. Otherwise, like once we reach in the lab, we will get confused. Like, oh, which location I have collected my sample. So we don't want to make any confusion for that thing. So once you reach in the each location, you have to note the latitude and longitude. Then thoroughly clean all sampling equipments like dredge, mixing tray, spoon, etc. with metal-free soap and deionized water prior to sampling at each site. Then soil sample should be collected using a stainless steel core sampler or trowel or shovel and collect 5 subsamples between 1 and 20 centimeter below the surface from area of 1 by 1 meter square. Then samples are collected in a stainless steel tray and stirred into a homogeneous mixture. Then samples are then placed into one or more separate glass jars. Ensure that waterproof labels on the containers, including the sampling site number, date of sampling, type of sample, and the name of the project. Here we used to make some errors, like we will take some markers to mark our sampling bottles. Like we will mark, suppose like A2, something like that we will mark. But the problem is that we don't know whether during the sampling day we will have some rain or there will be a chance of spilling of water to your bottle. Then once we reach in the laboratory, we can see that there is a fading of your marker, means the mark. Then you will get confusion. Oh, which sample I have this collected? This is A2 or B2, something like that. Then to avoid like this type of confusion, you have to cover your labeling with proper sellotape. That means you have to make sure that this is waterproof. Then we will go for the sediment sampling methodology. So we have to collect the sediment sample at a depth of up near to 60 centimeter below the water surface. Then the sampler should wade into the pond until the desired depth is reached, and then scoop sediments directly into sampling jars or by using a stainless steel pan. 3 individual samples should be collected at each site, and each sample should then transfer to the mixing pan, stirred into homogeneous mixture, and then placed into 3 separate pre-labeled glass jars. Same thing we have to repeat as what we have done for the soil, like identify the identify or locate our sediment sampling site, fill out the field data sheet, prepare a sampling jar. Then again, we have to put on our gloves, rinse gloves with clean water, then first scrub our equipment with sparkling, then rinse with clean water like 3 times, then rinse with acetone, then rinse with hexane. Now again, we are in the sediment sampling location. As I said like before, we have to first we have to note our latitude and longitude using our GPS system. Then always wear a new clean latex gloves while sampling. Then thoroughly clean all sampling equipment with metal-free soap and deionized water prior to sampling at each site. Then where possible, pond sediment should be collected from a depth at least like 50 to 60 centimeter below the water surface. Then the sampler should wade into the pond until the desired depth is reached. Then scoop your sediments directly into sampling jar or by using a stainless steel pan. Repeat the collection until you are getting your desired volume of sample or the quantity of sample. Then make a note that how many times you have done your grabbing. Then using the stainless steel spoon, mix the sediment sample until it is thoroughly combined into a single homogeneous sample in a mixing tray. Then they transfer representative subsamples of the homogeneous mixture to the clean sample jar using the mixing spoon. Then they fill the jar full as possible with the sample mixture, and if the sample will be frozen, be sure to leave some enough space, otherwise there will be a chance of breaking your bottle. Then ensure the label on the container, including the sampling site number, date of sampling, like type of soil, like soil or sediment, whatever it is. Now here for in this context, we have sediment, the name of the project, Then place clear plastic tape around the label to make it water resistant. After finishing all these things, we have to make one more checkup. Everything that we have done in a proper way from A to Z. We have done everything in a proper way or not. Then once we reach in the lab, we have like extraction and analysis. For the extraction, we will after the extraction, we will have like non-polar and polar compounds. For the non-polar, we will have the organochlorine pesticides, PCBs, PBDs, dioxin like PCBs, organophosphate. Then for the polar compound, we have perfluorinated compounds. Then we will do the extraction procedure like whatever the extraction procedure for the compound, we will follow that thing. Then we will have the 25 ml, and for the polar compound, we will have like a 10 ml sample. From the polar compound, we will go for directly for the LC mass. Then here we will do for some acid cleanup. Then we will have around 1 ml sample. We will concentrate this one and we will concentrate. Then we will make it to 1 ml sample. Then this 1 ml sample, we will split into 0.5 and 0.5 ml. And the first 0.5 ml, we will go for the activated silica cleanup. And the next 0.5 ml, we will go for the FMS cleanup. Then the first one, we will go with this while we will go for the GC mass for the PCB analysis and the GC mass for the OCPs, PBDs like that. And the next FMS cleanup part, we will have like these HRMS analysis for the dioxins and the dioxin like PCBs. So we have to make sure that from single, that is like from the sampling until the analysis, we have to be very careful because already we will have some unintentional errors will be happen because we have some instrumental errors and we have like some human errors. So we have to be very careful that you don't want to make any intentional errors, like means like if you are lazy or something like that, there is a possibility of errors will come. So this will reflect on your final result. And this is just not because of your dealing with the national important data. No, this is just like a scientific way that we have to carry every single step like in a very vigilant, and we have to do this trace analysis in a better manner. So that's all for now. Thank you so much.
Can I say something?
Yeah, please, Mikhail.
Yeah, that was very nice. It was very good. I have only one thing.
Yes, please.
Especially because of PCB, we very often have the problem that we don't have normal soil. We have sometimes concrete or asphalt below. Yeah. Okay. And the problem is, believe me or not, 30 years ago, I was a project manager in a contaminated site of a factory with hydraulic oil that contained about 1,500 ppm PCB. And that was a 40 centimeter concrete. And the concrete usually is white, is light in color. So, but the oil, the hydraulic oil darkens the concrete. So we had to build up, let me say, a tent around the area, and we have a vacuum system and fully protected people and so on to take off the concrete. And after a certain time, we took with a jackhammer, yeah, and we put it inside the tent into tongs and everything like that. Finally, the concrete got light, and my counterpart from the authority said, now it's PCB free. I said, no, please certify. I say, no, I will not certify because I do not know. We have to take another sample and we have to analyze again. And he said, oh, it costs money, and so on. I said, no, we stay. He went to his boss to my boss, and finally we came to the conclusion. We take a sample on cost taken over by our company if it's below 50 ppm. If it's above, the authorities have to pay. Finally, what we found more PCB than above because we have a chromatographic effect. And that's the problem always with chlorinated toxic substances, that they are heavy and they will penetrate with the time. And they go deeper and deeper. We found in this area, we found 9 meters deep, we found 2 ppm PCB. Yeah. So the deep is very important. It's very important as well later on if you excavate the contaminated soil, the contaminated concrete or whatsoever. That is absolutely important. Thank you.
Okay. So Mikhail, do you have any idea about how long it will penetrate under the soil? Means in what depth it will go, up to what depth?
No idea. No idea. That was that was a factory that operated with the hydraulic systems for a long time, and there were never studies. I always said there should be something, because that would be something for maybe a doctor work or something like that to find out. Because once the PCB starts at the surface, it goes down. The light PCBs, they will stop after a certain time. The composition of the PCBs, we have 209 congeners, and the technical mixer is about 100 congeners. So the heaviest congeners will go deepest, but I have never found some studies on that. That would be a nice work for maybe somebody in UNITA.
Yeah, thank you. Yeah, thank you for your comment. Yeah, thank you so much. And welcome. I think I can see Bilal and Ghassan. Bilal, please go ahead.
First of all, thank you for Yasar. Related to us, maybe most important to understand. Now you explained the sediment and the soil. The same procedure, can we use it for leach it from the landfill? Because maybe the optimum way in Palestine, there is a landfill in Palestine, so we can use it, the leach it that go out from this landfill. Second, the pathway for resin that you mentioned that for a human. But we see that the impact maybe for the not only for the human, the impact maybe goes to the bird and other issue. It's the same way. It's the same way. If the sediment, it's okay. The same procedure for taking the sample from the leachate. The same procedure for extraction.
Yeah. The same procedure. For the soil and the sediment sample, we will use the same extraction procedure. And and for
leachate that go out from the landfill, not the sediment. It's the leachate, semi-liquid.
Sorry, I didn't get you.
The leach that go out from the landfill.
Yeah, certainly, to assess landfills in respect to POPs release, it is the leachates. It might be interesting that you look to Australia. They had a larger project on POP release from landfills, and they also analyzed the groundwater under the landfills. I need to check if there is a public report on that. But what they have found is that especially the PFAS and the phosphorus flame retardants, they were in the groundwater at high levels.
One thing is important. If you take groundwater samples, you must look at the groundwater flow direction. You take one sample from outside, from where the flow comes from, and then you go through the landfill or the contaminated area, what it is, and then you take it behind. Because then you will see the difference in contamination.
Okay.
Michael, Roland, I did understand. The same procedure we can use it, or there is other methodology that we should use it when we wanted to sample it from the landfill? That's my question. And the same procedure for extraction or not?
The procedure finally is the same. You have just take a spot. You have let me say 10 square meter, and then you have on the right hand side the water, the groundwater goes from the right-hand side through your 10 square meter and goes to the left. Yeah. Then you take a sample from the right-hand side before the contaminated area or suspected contaminated area, and the same procedure you take from the contaminated area, and then you go to the left behind the contaminated area. You take again a sample in the same way, and you analyze. Then you know how big is the impact by this contaminated area to the non-contaminated area.
Michael, I cannot take it directly from the leachate because the leachate follow.
Bilal, can I explain for Muller and Roland?
Yes.
Dr. Roland and Michael, please be note that my colleague Bilal asking about the procedure how to collect the samples from the leachate. The leachate is the sewage that comes from the landfills. You know, there is like a semi-solid, or it's like it's water. It's water comes from the landfills and collected in the special ponds side of the cells, of the waste cells. So that is it a special process for collecting these samples from the leachate, or it's like water samples, or from the rivers, or from the ocean, like this?
Yeah, yeah. I mean, it is taking water samples, but afterwards in the cleanup, you have, like you said, you might have much particulates in it. Then there are different procedures. Also, US EPA. They have normally all their procedures online for free. When you have then this kind of water samples with many particulates, then normally you have a filtration, and then you analyze the filter and need to extract the filter and the water. Normally you have different shaking procedures with solvents. Yeah, but I think when you look to such studies, on leachates, normally the procedures is described, and I would recommend you to download the US EPA standards for that. Yeah, I mean, also there are for sure European standards, but normally the European standards you have to buy.
Ghassan, please. Ghassan.
Thank you. Actually, I have a couple of points as usual, but the first point already, I think you asked, and Michael already answered part of that. I wanted to ask about, is there any real study or a research about the profile of POPs in any contaminated site? I mean, with depth, how it goes, because as you mentioned in your protocol, about 10 centimeters depth, you have to collect the soil sample. So, and I think Michael said there isn't any kind of this study, if I'm right. The second point is, if you have any industrial activity which is expected to be a point of pollution, and it's let's say located in a paved area, which is I mean, already also Michael mentioned part of this point, and the flow, let's say, goes from the paved area to a nearby soil. Do you expect here the first point to be sampled is the nearest point of the soil near this activity? And that's it. Thank you. Oh, maybe I have one more point, maybe later, about the extraction process, what you mentioned, and the analysis. You mentioned acetone and hexane washings after the water. In your analysis, do you mean the analysis for the acetone fraction or the final fraction from hexane? And that's it. Thank you.
Sorry, I didn't get you.
When you presented the washings for the samples, you started with water washings, then acetone, then finally with hexane.
Yeah.
So the analysis you did for the hexane extract or acetone and hexane extract?
Yeah, this is depend
Because-
upon we have like a different extraction procedure, and normally we used to use these type of solvent like mixture of acetone and hexane, sometimes with the different ratios. That's why we used to wash with the same solvent in order to make any other contamination.
But usually you get some bulbs in acetone, or it's for sure to be in the last extraction with hexane. This
I
is my
think
point.
no, I think the acetone, I think what we are using is the pure one, I guess.
So you expect with acetone you don't get bulbs in that extract, right? This is what I understood.
Yeah, because we used to keep some like blank sample, means the same procedure what we are doing means like we used to use the blank sample, then we have to check there is any like blank concentration will be available there or not, then we have to make that correction as well.
And I mean, in respect to the depths of contamination, if you only have the normal deposition of POPs, the major concentration is in the first 10-15 centimeter. So from the normal deposition. If you have on a big contaminated sites of a chemical industry, there's one example from Hamburg, which have operated for several decades on the site. So here the pollution went down 50 meters. Yeah, and especially when you have the lighter chemicals like chlorobenzenes or solvents, then these pollutions can really go down. But if you have only a deposition, and I can send you a paper which we have recently done in Nigeria for the PBDEs around the landfills, and we have taken different soil layers. More than 90% were in the first 10 centimeters.
Thank you so much. This is a good one.
I can also send you the paper we have written on this production site of pesticide factory in Hamburg, where you see the details, including remediation activities.
I think there's another thing that is very important to remember. What is the site? Where is the site? Is it in the city? Is it, let me say, in a critical circumstances and so on? Because you have to decide whether you excavate up to, let me say, 2 ppm PCB or up to 50 ppm. Yeah. If you have, let me say, some critical kindergarten or school on top or close to it, you will go for a lower level of remaining PCB as an example, and that holds for the other pots as well. Yeah, you always have to consider what will be there or what is there in the neighborhood and what will be built on that or whatever.
Yeah, there is a new guidance from UNEP, from Stockholm Convention, about POP contaminated sites. And there are 5 phases of the assessment of contaminated sites. And what Michael just explained, this is in the first phase, where you look for the receptors around the contaminated sites, and it is called conceptual site model. And in your conceptual site model, you do all these information, including what is the surrounding, who could be contaminated, what is with the groundwater. So I can send the link to this toolkit or to this guidance, which is now in a draft stage, and at the moment there is a possibility for commenting. So you can look at it and you can comment and suggest improvements.
Because that will influence your works on the excavation. Yeah, how deep you go and how precisely you go and so on.
Okay, great. Bilal, do you have any more comments?
Just one comment related to the volume. There is any suggestion related to the volume related to the sediment or to the soil? There is any recommendation related to the volume, related to the depth? We understand that, but for the volume, for the sampling.
No, you have to carry like means after carrying your sample, of course, once you reach in the lab, you have to weigh your sample. Then means like it will be mentioned in the procedure that how much weight of your sample you have to collect. Then you have to start the extraction procedure using that weighed sample.
Well, one thing is very important. I had this situation in Lebanon, in Bauschri, that is a suburb of Beirut, where we assembled transformers. There was a storage of about 2,000 phase-out transformers, and we assembled randomly some transformers, and I took some soil samples. Actually, it was not soil, it was asphalt and sometimes concrete and so on. And the whole area, and that was about maybe 5,000 square meters, was covered with an oily surface. And all the samples I took, the PCB contamination was between 50 and 200 ppm, like that. So that is really very difficult and very challenging if you, let me say, have such an area, and I'm pretty sure we have that in Palestine as well. Then we have to have a big, let me say, study on the site, and we have a lot of spots for sampling. We have to make a roster over the whole area, and finally as well precisely determine the contamination at each corner more or less.